is available at the URL linked in the corner of the screen here, bit.ly/smart-FHIR-tech, and I'll keep that URL on the screen for the first couple of slides. One thing you might want to do if you follow along is click through to some of the examples. So whenever possible, I'll list full URLs on the screen, but some of them it's just easier to click through, especially if they're long. So my goal for the next 40 minutes is to give you an overview of the work that we've done on the Smart Health IT project over the years. This is something that actually started back in 2010, before FHIR came together, and then as the FHIR specification was coming along, we joined forces, and it's been incredible for me to see the progress of implementation and support that's come along for this set of APIs and this app platform over the years. I don't think I really could have predicted the broad adoption that we would see. So it's a real pleasure to get to talk with you about this. I'd love to keep this an interactive session, so I'll plan to save at least 5 minutes for questions at the end, but as we go through the presentation, by all means, if something comes up, if I say something that's not clear, or you just have a burning follow-up question, please raise your hand, and I'm happy to take questions as they come. So with that, let me dig into the presentation. Start off with a little bit of motivation. So back in 2017, we sponsored a kind of a survey, a report that a class organization did with healthcare provider organizations in the United States to try to understand the current state of play, back in 2017, around the adoption of third-party apps, or apps outside of the main EHR system inside of healthcare provider environments. And it resulted in the publication of this report. You can read it at the URL here. But we really just wanted to highlight one of the key themes that we heard from providers at the time, which was really there were a lot of apps, but they were too hard to use because they didn't integrate. So this quote really highlights it, which is we had this wonderful population health tool. We couldn't get our EHR system to interface with that tool. So we had to enter information by hand, and eventually we couldn't keep up, and we gave up on the tool. And this is still a really common experience for organizations that want to deploy technology alongside an existing installed base of health record systems inside of the clinical environment. And effectively, this is one of the major pain points that we try to tackle with the Smart on FHIR, or the Smart Health IT app platform. So said another way, this is really our core focus. On the one hand of the screen, we've got health applications. Organizations, individual development shops, startups, academic medical centers, lots of different groups can put together an application, all kinds of different functionality. In the demos that we show today, we're going to focus on some of the low-hanging fruit, so things like read-only access to clinical records, but in a structured, standardized way. So lots of groups writing apps. On the other hand, on the right side of this slide, you'll see many different kinds of clinical systems, some of which are what we would consider to be conventional EHR systems, so like the system of record inside of your hospital. But there's other kinds of systems too, things like data warehouses and patient portals, many different kinds of systems that can store healthcare data, and you'd like to be able to plug an app into these different kinds of systems in a consistent way. And so that's what we'll talk about here with the Smart Health IT project, is what is the glue that it takes to be able to plug apps into these different back-end systems consistently. And in broad strokes, first of all, there's this notion of user experience integration. So how do you actually embed an app inside of the screen real estate of an EHR system? Or how do you connect an app into a patient portal, for example? There's a couple of pieces around security. So how do you authorize an app to get access to just the data that it needs? And make sure that it doesn't get access to the data that it's not supposed to have? How do you let that app authenticate an end user so that people don't need to make a new account for every different app they use out of the course of their daily workflow, but they can share accounts and use that one account to sign into different applications? And then, of course, clinical data. And here at FHIR Developer Days, it's no surprise that we use FHIR for this last piece. But this is sort of the stack that we think about when we talk of a standards-based app platform, and we'll get into the details on each of these over the course of the next 30 minutes or so. So if you have a system like this, if you can handle user experience integration and authorization and sign-on and clinical data access, if you put those pieces together, what it really means is this notion that we originally described with the SMART project as substitutability. So SMART is an acronym. It stands for Substitutable Medical Apps and Reusable Technology. And the idea here was really we just wanted a handle on a word that was a little bit more specific than interoperability or interoperable. The words interoperable mean different things to different people. Sometimes it means just giving a human being access to a document. Sometimes it means two deeply integrated systems. And what we wanted to describe with SMART was this notion of apps that can plug into an environment. And so if you've got, for example, one patient scheduling management app that you've been using to keep track of your schedule for the day, but a better one gets published by another app developer, you should be able to swap out the old app and switch in the new one and keep going with all of your existing data in place. That's sort of the goal. That's the dream. So for users, what this concept of substitutability means is that you get your choice between different apps. Different users inside of an organization might have different preferred applications to get a specific task done, and you can upgrade when new features or new apps are developed. On the other hand, for app developers, this concept really gets down to barriers to entry. So you can build an app that can connect into multiple different systems without having to do a deep integration project with each system in turn. And this is especially powerful for organizations that build apps or build tools in-house. So when I was working on this project at Boston Children's Hospital, for example, there was an IT staff there that had enough bandwidth to build some local apps. So somebody in the cardiology department might say, we wish we had an app that could do this job around pediatric blood pressure. And it sometimes made sense to invest internal resources to build an app like that. But the audience was limited to just clinicians inside this one hospital. And so the level of effort you would put into building that app was still pretty low. You wouldn't give it a lot of polish and fit and finish and testing. It was very hard to justify that level of effort for such a local distribution. But with an API like this, suddenly it makes sense to put in that level of effort and polish, because this is an app that you can take and give away to other children's hospitals around the world. Or maybe in the context of a commercialization strategy, maybe it's something that you try to sell to organizations as part of a sustainability strategy. So this is sort of the basic benefit of this substitutability concept. And I think it's pretty straightforward. But in that model, EHRs, the systems of record inside of a healthcare organization, really become a standardized platform. And so they take care of some of the details that you wouldn't want to handle in every app independently. So things like managing users and patient accounts, integrating workflow, and building out core services for things like data persistence and regulatory compliance. All those things become platform capabilities, and app developers can focus on the value out of a particular use case that they're covering, relying on the platform for the rest. So that's the basic setup in terms of the value proposition here, and I want to give you a sense of how these components work. So I mentioned that we use standards everywhere possible, and we sprinkle in some extensions anywhere we have to. So for the launch piece, we describe this idea of an app that can run against or inside of or connected to an EHR system, and we use the Oauth standard for launching and authorizing an app. So Oauth is an open standard from IETF, the Internet Engineering Task Force. Oauth 2.0 is what we're using, and it's been around in some flavor for the better part of the decade. But it's a highly configurable kind of protocol, very much like FHIR. There's a lot of options. Some systems support one subset of options. Other systems support different subsets. And to make productive use of a standard like Oauth or a standard like FHIR, you need implementation guides that say, in our context, here's the particular parameters and fields that we'll use. These are the expectations that we can agree on ahead of time. So we published a set of specifications profiling Oauth. This is called the Smart App Launch Specification. And we actually standardized this through HL7 a couple of years ago. So there's a complete package of these standards now available through HL7. But the basic flow, well, there's two flavors. So we'll start with what I call the standalone app launch. And so the interaction here begins with a user who's running an app, and then they want to connect the app to the EHR. So it's sort of an app-first workflow that we'll talk about right now. And a great example of this would be for those of you who saw Apple's demonstrations of the health records connectivity capabilities of Apple's Health app, uses this same flow. So you start from the app connects you to a clinical system, and often the way that it knows which system to connect to is by asking the user. So in the health records example, it says, search for your healthcare provider using this widget. Once you figure out which healthcare provider you want to connect to, there's a HTTP redirect operation that happens. So you get opened in a web browser context to a clinical provider, in this case a patient portal, and you sign into that patient portal using your existing user account that you have with that healthcare provider organization. So we don't try to manage usernames and passwords. We don't expect a smart app to ever see a user's password. That all gets handled through this Oauth flow. So the patient signs in, or clinician signs in, on the EHR side, and performs an authorization step. So this is the point at which that user is telling the clinical data system, I want to run this app. It's okay to let this app have access to my data. And we'll talk about the details of what access means and how to do data subsets in a moment. But based on that decision, then the browser redirects back to the application, and the app gets what's called an access token that it can use when it wants to make FHIR API calls. So that's the basic workflow for the standalone app launch. Let me now tell you about one other way of launching apps, and this is the complement. So this is if you're starting from the EHR rather than starting from the app. And this happens all the time, for example, in a clinician-facing app where day in and day out, the clinician is using an existing EHR. So these would be systems from companies like Epic or Cerner or Allscripts or eClinicalWorks. A clinician is signed into that program all day long, opening up one patient record, seeing a patient, taking notes, moving on to the next patient. And inside of that EHR, there are typically different tabs for different kinds of clinical data. So you might have a tab that shows you medications or problems or vital signs. And using this integration pattern, you can effectively embed a smart app as one of those tabs. So a user clicks a specific button to launch an app, and then it launches inside of the physical real estate of the EHR. And the workflow looks almost identical to what I showed you in the standalone launch, except, of course, for the very first step, which sends you from the EHR to the app. So that's what happens when the app opens what could be an inline frame or a browser widget pointing to the app URL. So that's the basic integration pattern, and from there on it works the same way. The app begins the OAuth process, the user could sign in if they need to, approve the app if they need to, and they get sent back. Just a couple of quick notes on that process. One thing to highlight is when this process first begins, when the EHR opens up a browser window onto the app, it provides what's called a launch parameter. It's just an opaque string. It's a URL parameter called launch, which contains enough context so that when this whole process finishes, the EHR knows which app launch this is. It can keep track of all the relevant details associated with this handle. And then the other thing to mention, because it's important for clinician-facing apps, is this step here where the user would sign in and approve the app and give it specific permissions. The better way to think about it is it's a combination of the user and their clinical provider organization sort of policy making those decisions together. So usually a user doesn't have to actually type anything in or click any buttons if it's an EHR integrated app. Those steps happen automatically, but from the app's perspective, it's all the same. It does a redirect, and eventually it gets back an authorization code, and it continues on the workflow. But the general principle is we don't want to put extra steps in a user's everyday workflow if we can avoid it. And so for most of these EHR integrated apps, the process is seamless. The provider clicks a button, a couple of redirects happen under the hood, and the app launches embedded in the EHR. Let me just pause for a moment and see if there's questions at this stage before we get into the details. Okay. So I mentioned the notion that apps should be authorized to access the data they need and not the data they don't need. And one of the major mechanisms that we use for this is called Oauth Scopes. So an app can ask for a list of the scopes that it needs or the permissions that it needs when it launches. And we have a particular language or set of scopes that we define as part of the Smart App Launch Protocol. And all the scopes look sort of like this. They all start with what we call an access type. So in this case, it's a patient-level scope. And this is what an app uses if it wants to get access to data about a single patient. It's the most common thing for apps that are running on one record at a time embedded in the EHR. We don't know which patient we're going to be working with. It's up to the EHR to tell us which patient is currently open in the system, but we know we're going to have to get data about whatever patient that is. So this is a patient-level access type. And then we define the FHIR resource that we want to get access to. So in this case, this would be access to an immunization resource. And then after the period here, we say what type of permissions we need, which is either read or write or star, which today means read and write together. And so by building up a set of these permissions, an app can express the totality of the data that it wants to be authorized to access. So a simple app that's doing, for example, a growth chart might need access to historical height and weight data, as well as some basic patient demographics like age. So it could ask for the patient.read and the observation.read scopes inside of the single patient access paradigm. An app that was doing a richer view of a clinical data history, maybe an app that was pulling together a personal health record by aggregating all available data about an individual, might ask for something like patient star.read. So that is to say, give me read access to all the FHIR resources about this patient. An e-prescribing app might want access to something like medication order or medication request.write to be able to create new medications on a scratch pad. I should highlight the fact here that in many implementations of Smart, the focus has been on read access to data. So when we look at server capabilities, we'll see a lot more servers that can support things like reading patients and reading observations. Then we'll see servers that can support things like writing a medication prescription. We'll come back to that topic in a little bit. We've so far talked about patient-level access, but there's also what we call user-level access. So for a clinician, or even for maybe the head of a household who has access to data about themselves as well as their children, it's sometimes useful to be able to give an app access to all the patients that you can see. So for an example here, a clinician scheduling app might need to be able to access data about all the patients who have a scheduled appointment today, and so that app would ask for user-level permissions rather than data about one patient at a time. If you look closely at some of these definitions, you'll see that they're tied to FHIR resource types. There are some good reasons for this, mostly implementability. If you are building a FHIR server, it's very easy to tell whether a given scope allows access to a given resource or not, because you just look at the resource type and you look at the scopes, and then you know. So that's a real advantage. One of the disadvantages is these are not super expressive. So for example, think about this observation type. FHIR observations are quite broad. So yeah, they're used for vital signs like heights and weights and blood pressures, but they're also used for lab tests, social history, and so effectively, if an app asks for observations because it wants to do vital sign plotting, at the same time, it's getting access to your complete historical lab results. Might not be the level of granularity at which you want to share. So there's ongoing work to ask, how can we redesign these scopes in a way that makes more sense from an end-user authorization perspective, but that's also implementable for servers? Because we could go very deep down a patient-centered design track and then realize that what we had defined was not something that EHRs were actually able to support in real life. So that's the balancing act that we play here. This was the very first point in the design space, and it's been fairly broadly adopted. It's actually a really good starting point when you're running apps that you trust a fair amount. But if you want to be able to run apps that are less trusted, you probably need a more expressive scope model. So that's all that I'm going to say about that today, but we'll touch on this subject a little bit more in the session on advanced OAuth tomorrow. So if you're interested in a little bit more about scope design, that might be a good session. So I want to give you examples of a few of the projects that are running adjacent to Smart and organizations that we've been working with closely over the years, and then dig into some of our developer tools. So quick shout out to the Argonaut project. This was probably one of the turning points in Smart adoption in the US based on a set of regulatory requirements that were published by our Office of the National Coordinator for Health IT that said every EHR system needs to have a patient-facing API. And at the time, they didn't say it needed to be FHIR. They didn't say it needed to be standardized, but every vendor needed to have some kind of API. And the large vendors could see where ONC was going with this rule. They could see that in the future, FHIR was going to be a requirement, and they realized it would be super valuable if we could agree on how to do this with FHIR early, work out the kinks, and then submit that as a target for future regulations or future rules. So this Argonaut group came together as kind of an industry consortium back around 2015, and it's had participation from a number of the large electronic health record vendors, from some key academic medical centers and healthcare provider organizations in the US, as well as technology vendors. So Apple and Microsoft have joined in recent years. And there have been year-by-year sort of project definitions inside of Argonaut. But one of the earliest things that we took on was going through the Smart App Launch specification that I showed you, getting review from all the major participants, and with that design review, making improvements to the way that app launch specification worked. And I don't think we've got time to go through too many of these projects in detail, but I'll just mention a couple that are going to come up a little bit later today and at DevDays. So one is we've done work in the Argonaut group in a similar fashion, reviewing and improving the clinical decision support hooks specification. And we're continuing to do that work even in 2019 and 2020. So you'll hear in the very next slot, Carl Anderson from my team at Microsoft is going to be talking about work that we've done in this Argonaut group on clinical decision support and something called smart web messaging that I'll come to in a little bit. But each year, Argonaut picks out a set of projects and sort of makes progress on that front. It's worth saying something about adoption. So Ricky Bloomfield, who's now at Apple, back in 2015 was at Duke, and they were one of the first organizations to build support for these Smart on FHIR apps integrated into their live clinical environment. And they were so early that they didn't have support from their EHR vendor at the time. They needed to go and build a technology team and build kind of a proxy server on their own to be able to plug these apps in. But fast forward to today, and this is something that comes off the shelf from major EHR vendors. So now the Epic FHIR APIs are available at Duke and other organizations to plug these kinds of apps in at the point of care. So we've gone from a world of early adopters and shoehorning and sort of difficult but possible to a world where this technology is coming off the shelf. And as we've made that transition, one of our goals has been to let the community know what apps are available, what's out there, make it very easy for developers to sort of advertise what they've built, and for various kinds of app users to discover what those things are. So whether it's a clinician-facing app or a patient-facing app, we wanted to make that process as simple as possible. So we launched a smart app gallery, which is a place where anybody can come and list an app, and it's free, and we basically just ask app developers to describe their app, and describe which EHR systems it's integrated into so that end users can filter by their system if they want to look at apps that are compatible, or they can just apply broad filters if they want to get a sense of what's out there. It's worth doing a very quick demo of the apps gallery, mostly just to show you how the navigation works and then to show you what is one of my favorite features of the gallery. So the home screen has just a listing of all applications. There's categories in the left-hand column so that you can drill down into a particular type of apps. And I'll show you just one example of a listing in the medication category, which is from a company called Polyglot. They recently joined the team at First Data Bank. And this is an app that does medication instruction translations into over 18 languages. And it's a really cool example of something that is extremely useful, but outside of the skill set of core electronic health record products. So you would never expect a big EHR vendor to invest all their own resources in developing this kind of a rich translation library across so many languages, but it's incredibly important. I mean, just think about a patient who comes into the emergency department and they're a Russian-speaking patient, and you're going to prescribe antibiotics for them to take at home, and you give them a printout in English, and maybe it's at a font size that's so small that they can't read it. That printout is not going to do a lot of good, but with an app like this, you can tailor those instructions to a patient's needs. And I won't go through the details of how this works, but I just want to show you the gallery features. So each app listing comes with a description, some screenshots, and then information about which versions of FHIR it's compatible with, and which EHRs it's available in. So this is an app that you can integrate today in Athena Health and Epic and Cerner, but not yet Allscripts. So that's the kind of information that you can get from the gallery itself. And then my favorite feature is this Try App button. So as a developer, when you register your app with the gallery, you don't have to enable this button, but it's strongly encouraged, because if you do, then people who are browsing the gallery can click the button and get a sense of how your app works against some sample data. I'll show you a little bit more about how the sample data system works in a couple minutes, but for the moment, I'm just going to pick one of the 3 sample patients that works best with this app. So the developer would have chosen these 3 patients because they have interesting medication lists, and so it sort of best shows off the features of the app itself. And now under the hood, what's happening is the app just went through that OAuth launch process. It got an access token. It used the token to fetch a medication list from the FHIR API, and it's displaying it here for a clinician to see. But then it provides these translation options. So if I want to print out a Russian language set of instructions in extra large font, then I can send a patient home with these kinds of instructions. It'll generate PDFs for each individual medication, as well as an overall summary. And these things have been designed, and they've gone through a user testing process with a whole system of icons that lets you know what time of day to take the med. And this doesn't totally look like Russian now that I'm zooming in, because I don't speak Russian, and I can read this. That maybe I need to do a better job of clicking this button. That's the fun thing about live demos. I'll give this a moment. Okay, so if I click the right button, I'll get the Russian language version of what we just saw. So that's an example of an app using the Try App button inside of a Smart App Gallery. Zooming out then to a couple of the other related efforts, sort of next to Smart Apps, one effort that we've been, again, proud to see grow in adoption over the course of the last couple of years has been clinical decision support hooks, CDS hooks. So this is an app that started with my team this is a specification, a standard, that started with my team at Boston Children's Hospital, and over the years has grown into a formal HL7 specification at cdshooks.org, We're currently at what we call version 1.0 of that specification. It would have been nice to do this presentation earlier, but those of you who saw Dennis Patterson's overview of CDS hooks, you know what's up with this specification. But it's been a collaboration, again, across EHR vendors, decision support vendors, and the goal here is to be able to automate more calls from an EHR to an external service. So launching an app is great, but users don't always know what app to launch, and this provides a way to be able to provide suggestions automatically in a sort of ambient way inside the context of the EHR. And then a forward pointer to a presentation that Carl is doing in the next slot on smart web messaging. So this is a set of technologies for doing better integration. Once a smart app has launched, how does it communicate back with the EHR that it's running inside of? So this allows an app to do things like signal to the EHR to say, I'm done, you can close me now, or signal to the EHR to say, I'm done, and it would be good if you navigated to this particular screen as a next step, or otherwise interact with some of the draft information that's available inside of the EHR's UI. So that's a session if you want to learn more on web messaging that's coming up next. But this is a draft specification at a relatively early stage. I'm going to skip the shout out to the bulk data spec, but if you're interested in learning about working with data at the population level, we're going to do a talk tomorrow morning on FHIR bulk data. And then this technology, in addition to serving healthcare providers and patients, is also super useful in a research context. So often research studies want to be able to look at many facets of an individual research participant's life. So it might involve surveys, it might involve drawing blood and running lab tests, but also having access to historical EHR data can be incredibly important. So you can figure out over the last decade, perhaps, how did this patient's blood tests evolve? And that's the kind of thing that you can get from these APIs. So very powerful for research use cases as well. I want to spend a few minutes and tell you about some of the tools that we've built, maybe starting with a quick demo. So first off is what we call the Smart App Launcher. This lives at launch.smarthealthit.org. And this is a web tool that you can use to basically configure a FHIR server. There's a bunch of knobs and dials that you can turn, and I won't get into all of them, but I'll give you enough to give you a sense of what's happening. And once you configure the launcher, you can test your app. You can launch your app against that particular configuration. So for example, you can have it simulate what it looks like to embed an app in the EHR, or not, depending on what you want to see. You can have it simulate a provider-facing EHR launch, or you can have it simulate a patient-facing standalone launch. So you choose the details of what part of the spec you want to test out with your app. You choose which version of the FHIR specification you want to use. And then at the bottom of the screen, once you configure all of these details, you get your very own FHIR server URL. And this URL basically embodies all the configuration details that you just provided. Under the hood, all those details are getting embedded in this little bit of base64 encoded JSON, but that's an implementation detail. Your app can treat this URL just like a full-blown FHIR server that just happens to use the version of FHIR and all the details that you've pre-configured. And it even has some developer-facing functions like sometimes it's hard to test how your app performs in an error condition, like if something goes wrong during the authorization process. But here under the advanced settings, you can say, I want to simulate an authorization error where I have an expired token, for example. I want to see what happens and make sure that I can test out that code path in my app. So you can configure a FHIR server that will always pretend like the token is invalid, and then you can test your app against that server to see how it behaves. So the launcher comes with this whole kind of feature set, and I'll show you an example of building an app against that launcher. So this is using a tool called glitch.com, which is sort of an openly editable, forkable code hosting platform. So you can click through the link in my presentation and fork off your own copy of this app and try it out for yourself. But basically, a smart app has two main functions, and I'll take you through each of them in a little detail so you can see what's happening under the hood. The first page for a standalone launch, by convention, we'll call that standalone.html or launch.html, but it doesn't need to be a special page and it doesn't need a special name. But the job of that one page is to begin the Oauth authorization process. So in this case, we're using a FHIR client library, which is available open source on GitHub, and we're calling the FHIR.oauth2.authorize function. And this is what kicks off the Oauth dance or workflow that we talked about earlier. It sends the user over to the EHR for approval. And once the user approves the app, the EHR redirects back to this index.html page. And this page loads the same FHIR library, But now the authorization process has been completed, and so the app can actually start to do its work. In this case, it's going to say, once OAuth 2 is ready, so this is a JavaScript promise that's going to resolve once we've got an access token. Then we're going to go and fetch some hemoglobin A1C data. So we're going to do a FHIR API search based on the observation resource type. We'll look for all observations with this particular code, which is a code for hemoglobin A1C. And then we're going to just iterate through all of the bundle entries, all the observations we get back from that search. Once we iterate through each one, we're going to pull out a date, and we're going to pull out the A1C value and just make a couple of arrays, and then call the plotly library to make a chart. And I won't go into the details of the plotting, but it's just described by this JSON configuration object that passes in values and axis labels and titles for the chart, all that kind of stuff. So in about 60 lines of JavaScript, we've seen an app that can authorize, connect to the EHR, and then make a plot. So let's see if we can do that in action. Rather than looking at the code, I'm going to look at the hosted version of the code. So everything that you edit at glitch.com becomes available at your subdomain.glitch.me. So I'll click the link here to the standalone launch, and what happens is it redirects me to the Smart App Launcher. I'm going to quote-unquote log in, but this is using just a canned ID. It's pre-filled for me. All I have to do is click through it. And then I mentioned that an end user can approve access for an app. So this screen is what's indicating that I'm going to give this app access to my patient demographics and observations for the currently selected patient. And once I approve it, this is going to complete the OAuth dance. I'm sent back to the app, which is being hosted at glitch.me. The app very quickly got an access token, fetched A1C values, and made this plot. So that's what's happening under the hood. It's a quick view of how you can use the launcher to launch an app, and you should be able to click through these same links and try things out on your own. I won't go through the EHR launch version of the same example, but similarly, we could show what it looks like to start from the launcher, the simulated EHR, and then redirect to the app from there. So the other kinds of support that we provide beyond a sandbox and this reference implementation include things like software libraries for developers who want to work with this. So I showed you an example of the JavaScript library a moment ago. There's actually a newer JavaScript library that came out earlier this year. So if you're just starting with Smart on FHIR and JavaScript, the sort of version 2 library is a great place to start. But some of these libraries were originally created by the Smart team. Others have been created by folks in the community, but a variety of languages and platforms on which you can start to build. But I want to emphasize you don't need one of these libraries. They're a very convenient starting point. But under the hood, it's just OAuth and FHIR with a particular set of constraints on top. So you can actually build a standalone app with no library support if you want to. We also have a set of open source apps. These are mostly static web applications, so HTML5 and JavaScript applications, similar to what I showed you with the hemoglobin example, but that do sort of richer, clinically interesting functionality. So we've built tools over the years like a growth chart application or a pediatric blood pressure display application based on real-world clinical needs. And so these are apps that have been put in production at Boston Children's Hospital and elsewhere. So I showed you one sandbox. I showed you the Smart App Launcher, which is a great place to go and test smart apps. But I would be remiss if I didn't mention there's a whole ecosystem of places where you can run and test these apps, and a whole spectrum from developer-facing utilities to like real-world deployment. So you can go to the Cerner sandbox or the Epic sandbox and test the way your app integrates with a real production EHR environment. You can go to the HSPC sandbox. Nikolai did a demonstration during the first 2 sessions this morning about the rich feature set that you can spin up there for controlling data in an endpoint that is all yours, and you can load all your own data into it and have an isolated environment. So lots of places you can go to test out these applications. My general advice for people who are getting started is it's very easy to start with one of the standalone sandboxes, so something like Smart or HSPC. Get your app working there, and then very quickly move over to some of the vendor sandboxes to figure out what works and what doesn't. Because honestly, I started this talk with the promise of plug and play. So you write an app once, you use these standard APIs, you plug it into all the places, and what I would say is that's sort of true. And it's generally more true year over year. But there are still pain points. There are still gaps and differences between exactly which resources different vendors support, or even inside of these data models, these FHIR resources, which elements you can expect to be consistently populated. Some systems point to a medication by reference, others point to it by an RX norm code. And once you start to understand this variability, you can account for it in your app's code. You can code for it. Some of it winds up being a special case by vendor, but most of it just winds up being, well, there are 3 ways to do this in FHIR, and I want to have a branch in my code to make sure that I treat each of these 3 ways appropriately and don't make too many assumptions. But this is something that you start to feel out as you build apps over time. So that's a tour of some of what we've built. Let me pause at this point. I think we've got about 5 minutes left if there are questions. Happy to entertain anything from what I've showed you to other pieces of the ecosystem. Question, yeah.
So how much of the sort of normalized information content is smart?
So the question is, how much of the normalized information content is smart? And let me give you a quick historical perspective and see if I've answered the question then. So when we started this project, we didn't have a lot of FHIR profiles out there in the community. So we put together a couple of markdown pages on the Smart Wiki, and we said, if you're doing Smart on FHIR app launch, you should try to support these FHIR resources and these vocabularies and basically follow these data modeling practices. And we didn't publish them as formal FHIR profiles. It's just a markdown page that developers could read. Over time, the Argonaut project took this on and actually formalized those concepts in FHIR profiles that made sense for the United States, for the US healthcare environment. And those in turn were formalized through HL7 in a set of profiles called the US Core. And so the current state of affairs in the US is we have these sort of national data summary profiles for what's called the core data set. And we expect that Smart on FHIR implementations in that context should follow these profiles. And generally speaking, in other jurisdictions, we think that the sort of the best practice is to develop profiles at a similar level, the strongest agreement that you can get within your jurisdiction. Does that answer the question?
Yeah, but I guess that leads to then what this smart do you have, what's your strategy for addressing other markets?
So from the perspective of the Smart Health IT project today, we're really focused on a lot of the technologies around app integration, app launch, security, that sort of rich integration. We're not so focused on the data modeling in FHIR because so many communities have sprung up to try to build those data-specific or query-specific IGs. So it's a little bit out of scope for the core SMART effort in 2019. We did just as much as we needed to in the past to cover this. Other questions, comments? Yeah, please. Yeah, so the question is, in our gallery, what happens to mobile applications? I showed you examples of web applications sort of throughout the talk. What about other platforms? So the short answer is, this set of APIs works with any application that can do an OAuth launch and then connect to a REST API server. So that includes web apps, it includes native mobile apps, native Windows or desktop apps. All those things are in scope. In terms of what we can show usefully in the gallery, web apps are obviously the easiest thing to demonstrate in a web-based gallery, but you can do, I think you can even filter by mobile applications in the gallery. You won't have the try it button on most of them, although we've played a little bit with things like linking to an app simulator to show that. And we have libraries for building an app in some of the native mobile platforms. So there's Swift libraries that Pascal originally authored and that are now being maintained in the community. Other questions, comments? All right, please grab me afterwards if anything else comes up. Thanks so much for your attention.